So, hello everyone. Hope you all are doing good. So, after a few days, we are having the exam that is a very important exam, that is a control system for ECE 4th Sem engineers. So, as per your huge demand, we are providing you all some of the important passing package. I know that the passing package to create this subject is a must because all of you are waiting for this passing package, but I'm trying my best to provide some of the important kind of questions that would be appearing for this exam. I would be saying you what type of questions would be appearing from all the modules in detail. Okay, I've referred all of the previous year question papers and came you all with some of the important type of questions because the questions are not repeated because in all the previous year question papers which I have referred, the questions related to mechanical system, signal flow graph, block diagrams are not repeated. They are in each question papers they would be providing different kind of systems. Okay, but here in this video I am going to provide you some of the important kind of problems that would be appearing. Okay, and in brief I would be telling you what kind of problems would be coming from all the modules. Okay, I know that from module 5 the concept related to Bode plot and Nyquist plot are pending to do. I would be providing it that video within tomorrow. Okay, so please stay tuned to our channel, and also I want you all to please like this video to a huge number. Okay, I want all of you to hit the like button and then proceed with this video. So let's discuss some of the important concepts, and also while discussing the concepts I would be providing you some of the video tags would be appearing on the top right of your screen. Okay, if you want you can click on that and refer those important concept videos as well, since we have already created the playlists for you all of all the concepts from module 1 to 4, and module 5 would be providing you within a short time. So please stay tuned to our channel, and let's start with some of the important concepts. Okay, so from module 1, we all know that from module 1 we don't have much concepts. One concept related to mechanical system conversion, they would be asking you either one translational mechanical system or one rotational mechanical system to write its equivalent mechanical circuit and represent them in force voltage as well as force current analogous circuit. Okay, this question would be must. Okay, they would be giving you one translational mechanical system or either one rotational mechanical system. For that we should be converting it to the equivalent mechanical system by representing the all the displacements. Okay, mostly in all of the cases the masses wherever is there only the displacement would be occurring, but how much ever displacement would be there represented by in the nodes, and what and all the components present you should be writing within their nodes in parallel. Okay, what and all are the components present between the two nodes, you should be writing them between the two nodes. Okay, then we should be writing the equilibrium equations. Okay, and represent it in force voltage analogy and force current analogy. Also I told you, right, for force voltage analogous circuit always we should be writing it using the loop analysis, the loop currents. Okay, and each loop in all the components in each loop would be connected in series. Okay, similarly for force current analogous circuit, the voltages would be we should be representing it in nodes, since we are using it by using the node voltages, and all the components inside the force current analogy should be connected in parallel. Okay, along with one current source. Okay, so one question related to one translational mechanical system would be must. Okay, also one question related to rotational mechanical system they might be asking here. Okay, so here there would nothing much changes. One change is that the displacement would be replaced by one angular displacement, force would be replaced by torque, and the mass would be replaced by the moment of inertia. Then rest of the spring and the frictional constant would be remaining as it is. Okay, then the same thing here as it is, same thing, how many displacements are there should be representing it there in nodes. It won't be changing. Okay, rest all the steps would be remaining as it is. Write the equilibrium equations for each nodes, then after that represent it in force voltage and force current analogous circuit. They would be mentioning it either both the force voltage or force current, or they would be mentioning any one of them, that is either force voltage or force current. Okay, so one question related to translational as well as rotational in choice they might be asking it, so please note it down. And also from module 1, one question they would be asking like this, like they would be giving you either one FV analogous or one FI analogous circuit like this. So here if you see that, if we see that this is, we can see that it is an FV analogous circuit, since we are having the loop currents along with the components. Using this circuit they would be asking you to analyze this circuit and develop a translational mechanical system or a rotational mechanical system using FV analogous or FI analogous circuit. Okay, this like this one question would be definitely asked. They would be giving you one circuit. For this we should be converting this to a translational mechanical system. In this case, what we should be doing is, I have already told you, discussed this in the model paper concept. So how much ever loops are there here, the 5 loop currents in this case, so 5 displacements. Okay, so for each loop, for loop I1, you should be writing the equation, okay, using the KVL. We should be representing that equation in S domain. Okay, in S domain we know that L is replaced by L1 into S, C is replaced by 1 by Cs, and R is replaced by Rs. Okay, so in one by one in all the loops we should be applying KVL, then take the inverse Laplace transform in order to represent it in T domain. Okay, then write its equation here, then represent it in T domain. For all the 5 loops you should be doing it as it is. Then after doing for all the 5 loops, then you should be comparing all the equations which you have marked it as equation 1, 2, 3, 4, 5. Using that, first you should mark the nodes of all the 5 displacements x1, x2, x3, x4, x5. Then necessary components you should be marking it them, and this is the equivalent mechanical system. You should be converting it to a translational system, okay, by representing first the masses. Okay, it would be easier. Okay, since here in the first displacement we are having m1 and k1, so that's why connect one mass here and one displacement, and above that mass mark for the first displacement here. Okay, like this the translation mechanical system you should be building. So one question related to this kind of question would be asked, where they would be giving either one force voltage or force current analogous circuit, that you should be converting it to one first the mechanical system, then using the mechanical system you should be converting it to the translational system. Okay, so these kind of questions would be asking, they would be asking from module 1. Okay, so let's discuss module 2 now. So from module 2, as you all know that one question related to block diagram reduction would be definitely asked. Okay, but not one simple block diagram reduction. They would be giving you one complex block diagram reduction circuit. Okay, as I've already told in my concept videos of block diagram reduction circuit. Okay, for block diagram reduction circuit, what we should be doing is, all the summing points we should be representing it using the minor loops. Whatever we have, we should be trying to reduce it by using the block diagram rules. That is, we know that whenever we have constant summing points in series and the branch which is associated to that, so those summing points we can be exchanging those branches. And also the other rule is that to shifting the summing point and takeoff point behind and in front of the block, what would be the changes? That is, whenever we shift a summing point behind the block, we should the block would be getting divided by 1 by g, and whenever we shift any summing point in front of the block would be getting multiplied into g. Similarly for a takeoff point, whenever we shift takeoff point behind the block, it would be getting multiplied, and whenever we shift takeoff point in front of the block, it would be getting divided. Okay, so these are some of the rules. Using those rules you should be trying to solve block diagram reduction. Also, if you want to refer some more videos related to block diagram reduction, it is available in our playlist. Okay, we have solved around 3 to 4 problems related to block diagram reduction, so you can refer it. Okay, and also the videos related to translational rotational mechanical system, it is available in our channel playlist. We have created it, so please visit that in order to get clear about the concept related to block diagram reduction, so that you can face the questions while you write the exam. Okay, so one question related to block diagram reduction they would be must asking. Okay, you should be remembering all the rules thoroughly, and one by one, from step by step. From first step, what you should be seeing is whether we have any minor loop or not. Okay, in first step only, if we see any minor loop, what we should be doing is we should be reducing that, and we should be trying to remove the summing points. Our goal in this block diagram reduction is we should try to eliminate the summing points as much as possible. Okay, by shifting either summing point or takeoff point. Okay, and the next thing what we should be doing is we should be seeing that whether two blocks are in series. So here we can see that these two are in series, but we have one takeoff point between them. What we should be doing is we should be trying to eliminate this takeoff point from this position by shifting it either front or back, so that the blocks would be in series, they would be converted into a single block. Okay, so our main aim is to eliminate the summing points as well as to convert multiple blocks into single blocks. Okay, yeah. So this one block diagram reduction question would be asked definitely. And also one question related to, they would be giving you one circuit here, and using this circuit or one network, we should be trying to obtain the block diagram. Okay, this also is multiple times repeated, but the questions are not the same. The questions would be changed definitely, but I am providing you the questions which are similar to what would be appearing for the exam. Okay, these kind of questions would be coming like this. They would be giving you one circuit here, and using that we should be applying KVL, and whatever the equations you get, you should be representing it like this by applying the KVL like this. I'm just going to scroll it down. You can pause the video and refer it. Okay, apply the KVL, try to write the equations, and separately for all the equations like this you represent it, and like this the block diagram would be represented in this case. So here in the gain path you should be writing all the resistances, and here wherever the I1 and V1 are there you should be representing like this. So here you can see that we have V1 into 1 by R1, 1 by R1 plus R2, so that here V1 would be coming, and here since we have one plus sign here, so that's why this I1 would be the summing point for these two blocks. Okay, that is 1 by R1 plus R2 and R2 by R1 plus R2. These both would be getting summed up, and this block we should be naming it as I1. Okay, that I1 is in the output side here. Okay, yeah, then this is I2 here it's getting multiplied, and V1 is getting multiplied. Okay, like this similarly for all these three equations, and try to write the final block diagram. Okay, yeah, so this kind of question would be definitely asked. And one question related to signal flow graph, they won't using Mason's gain formula. Okay, they would be definitely asking signal flow graph, but not direct question. They would be giving you one block diagram, and for that block diagram you should be converting that block diagram into the standard signal flow graph, and try to write the forward paths, loop gains for the signal flow graph, and in using Mason's gain formula you should find the relationship of the transfer function, that is C of S by R of S. Okay, so in this case also we have solved one few problems, in also model paper also we have solved these kind of problems, so you can refer it down. What to do is we should be replacing all the summing points and takeoff point by the nodes, and all the branches, all the directions mentioned along with the sign plus or minus, you should be representing it, and all the gains which and all are the blocks are given between the summing point and takeoff point, the shifting of all the branches here you should be representing by one lines here like this, signal flow graph, all the graphs we should be plotting, and you should be representing like this. Okay, and using that, here in this case what we should be doing is all the summing points and takeoff points you should be representing by one dots here, nodes. Okay, so here you can see that we have 1 2 3 4 5 6 7 8 9. So we have 9 summing points and takeoff points in a single line, so that's why in a single line we should be drawing 9 dots here, and also from this takeoff point to this summing point we are having one curve here like this, and the feedback path is named as G4, so it is moving in this direction here, so that's why we are giving it direction in this direction, and you naming it as G4. Okay, similarly all of the terms you should be doing naming it, and try to find the feedback forward paths, loops, and non-touching loops taken 2 at a time, 3 at a time, like that we should be solving it, and delta 1, delta 2 using forward paths, that is we should be touching 1 minus loop gains which are not touching the forward path, you should be mentioning that, and if the loop gains are touching that forward path we should be writing it as 0. Okay, so these kind of questions would be asked. Okay, also direct questions related to signal flow graph, they would be giving you like this, they would be giving one question here also for this signal flow graph you should be directly writing the Mason's gain formula, but I don't think so this kind of question would be asked, because from module 1 and module 2 the weightage of each question is mostly 10 marks. Okay, so for 10 marks they won't be giving you such simple signal flow graphs, they would be giving you one block diagram. For that you should be trying to construct the signal flow graph, and that signal flow graph you should be using and solving the for forward paths, loop gains, and all of them. Okay, yeah, so from module 1 and module 2 mostly all of the question would be having the weightage of 10 marks. Okay, and from module 3 we should be knowing the static error coefficients Kp, Kv, Ka, and the formulas for steady state errors for type 0, type 1 and type 2 systems respectively. Okay, so here this is one table, we have already discussed these kind of videos in our concept videos which have created the playlist. Okay, those who have not seen it you can refer it. Okay, it would be appearing in the top right of your screens, or you can refer our playlist. Okay, all the video tags we are available. Okay, also you can refer our playlist. Okay, so one question related to these static error coefficient, the problems they would be asking. Okay, And also one question related to effect of change in G of S into H of S for different types of system, that is type 0, type 1, type 2 system. And also the given input, they would be selected, the input selected should be of step input, ramp input, as well as parabolic input. Okay, so these kind of question also would be asking. So typically they would be mentioning any one type of system. Okay, for that type of system you should be applying all the three kind of inputs, that is step input, ramp input, and parabolic input, and we should be checking for the effect of change in G of S into H of S. That is this is the general formula for that. Okay, hope you might be knowing it. If you want to brief explanation about this, it is available in our channel. You can refer our playlist and click on these kind of videos. Okay, one question related to this would be definitely asked, where you should be finding the value of steady state error for in case of type 0 or a type 1 or type 2 system for all the three kinds of inputs, that is step input, ramp input, and parabolic input. So one question related to this they would be asking for sure. Okay, and also like this kind of questions would be asked in problems. Okay, that is they would be giving you one unity feedback system like this, the transfer function they would be giving you like this, and then they would be asking these kind of sub questions like this, that is you should be determining the type of system by seeing the transfer function. Also you should be finding the values of kp, kv, ka, that is positional error constant, velocity error coefficient, and acceleration error coefficient. Okay, and error for ramp with input magnitude 4. Like this they would be asking the questions. Okay, you should be substituting the values of kp, kv, and ka. Okay, these are the formulas and these are the substitutions, and like this you should be solving. Okay, yeah, so this any from this any one question would be definitely asked related to these finding the value of kp, kv, ka. They would be giving you a transfer function and you should be finding it. Okay, this question would be definitely asked. And now some of the important derivations I am going to tell you all from module 3. So one of two important derivations which you need to study before writing the exam from this module is, that is one derivation of peak time. Okay, derivation of peak time is very important. Okay, the derivation of peak time is very important. Along with that, the derivation of peak overshoot, that is MP. Both of its derivation, it's available in our channel. We have beautifully created it in the playlist section. You can see those derivations. Okay, so here I cannot be showing you all the derivation part. Okay, so derivations related to peak time and peak overshoot are definitely asked. It is multiple times repeated. So I am assuring you all to please learn these two derivations first, that is derivation of peak time as well as peak overshoot. Okay, any one of them would be asked as a sub question for 6 to 7 marks. Okay, so derivation of peak time and peak overshoot is a must question, so you should be learning that. Okay, derivation, it is available in our channel. Okay, and also if they ask the derivation separately for rise time and settling time, they won't be asking it as a single question, they would be asking as a sub question. For example, if they ask the question to derive the peak overshoot, along with that you would be asking you to derive either rise time or settling time, because it does not carry much steps here. Okay, it is one it is consists of only half or 3/4 page, so that's why they won't be asking it separately. Either they might be asking to a derivation of any two components in a single question, or they would be asking separately to derive peak time and peak overshoot. Okay, but the important derivations are related to peak time and peak overshoot. Those two derivations you should be learning it for sure. Okay, yeah. And also one question related to the finding all the time domain specifications, that is rise time, peak time, delay time, settling time, peak time, peak overshoot, all of them using their formulas, direct substitution they would be asking. First they would be giving you either the like this one simple block diagram with some minor loop like this. Okay, for that you should be writing the transfer function and you should be obtaining it first, or else they would be giving directly the transfer function in the question only. Okay, using that you should be finding all the time domain specifications, that is omega d, omega n, zeta. Okay, that by comparing it with the transfer function, that is this form you should be converting it to omega n square divided by s square plus 2 zeta omega ns plus omega n square, and you should be writing the values of omega n and zeta. Okay, then after that all the time domain specifications. Okay, these kind of problems would be definitely asked. Okay, so these problems related to this module, it's very easy, so you can refer it down. And all the derivations from this module are very important, that is one derivation related to peak time and one derivation related to peak overshoot, also one derivation related to frequency response for the second order control system. So that derivation is also very important. That also we have created the video for you all. You can refer it down. It's available in our channel. Okay. So from module 4, stability analysis, One question related to route array would be definitely asked, not simple problems of route array. What they would be asking is, they would be asking to analyze the stability of the system using RH criteria. They would be giving you one characteristic equation. Like this, they would be twisting the questions and asking that how many roots of the equation are on the imaginary axis or on the right half of the S-plane. Like that twisted questions they would be asking related to stability analysis, where using the characteristic equation you should be writing the route array. Okay, and also we have discussed some of the special cases, right? That is whether in the first column whether any term would be 0, you should be using either two methods, that is one is epsilon method or replacing s by 1 by z. Okay, these are the two methods whenever we get any in the first column whenever you get 0, and also one more special case is whenever we get any row of zeros, that is one full row, if we get all of them as 0, that by using that row of zeros, how can we replace that row of zeros? That is, we should be checking for the just above row of that row of zeros, that we should be writing it as auxiliary equation. That auxiliary equation, by using that, we should be taking its derivative, and whatever the coefficients we get after taking the derivative, we should be replacing it by row of zeros and continue the calculation. That is one more special case. Okay, so these kind of problems related to stability analysis they would be definitely asking. Okay, so they would be giving the characteristic equation and route array, and also the brief description of this, it is available in our channel. You can refer all of our videos. It is, we have separately made the playlist for you all. So one question related to route array would be definitely asked, and also one question is must related to analyzing the range of k. Okay, that is, they would be giving you one transfer function. For that you should be trying to reduce the transfer function and writing the characteristic equation. Okay, by using the denominator of the transfer function, apply the route array, then try to find the marginal value of k. Okay, such that the system oscillates, and what is the corresponding frequency of oscillation. Okay, that is, like this you should be writing the route array. So here most of the cases the last s power 0 element would be k. Okay, for that you should be finding the range of k, then range of k margin by equating k equal to k margin, so that we get the row of zeros. Okay, the whatever value of k margin we get, from that we should be trying to write the auxiliary equation, substitute the value of k margin, and like this form we should be getting in s is equal to plus or minus j omega, so that we get the frequency of oscillations. Okay, using this plus or minus j omega term. Okay, so this kind of question would be definitely asked related to frequency of oscillations. To find the frequency of oscillation, one question would be definitely asked. And one very important type of question that multiple times repeated is, in route array calculation, what they would be asking is, they won't be giving you direct data, that is, they won't be giving you the direct transfer function. Sometimes they would be giving you like this, that is, in its open loop transfer function has poles at s is equal to 0, 1, 2 and zeros at s is equal to 5, and gain k of forward path is 10. Like this they would be giving you the data. Using this data we should be trying to write the transfer function. Okay, that is, we know that in the transfer function the poles would be placing in the denominator side, that is, whenever the denominator side equal to 0 you would be getting the poles, and whenever the numerator is equal to 0 you would be getting the zeros. Okay, like this you should be trying to write the transfer function, and then you should be applying the route array. So these kind of question also they would be asking definitely. And one definite question, as you all might be knowing it, the one definite question is definitely related to root locus. Okay, so I won't be telling you which are all kind of questions will be asked, but in our channel we have created 6 different kinds of problems, okay, for root locus, in order to make you clear about this concept. In brief, we have discussed all of the kinds of problems related to root locus. 6 different kinds of problems, it's available in our channel. Okay, all of different kinds. If you want, you can check that video, so that you would be thorough about what kind of problems would be appearing for the exam. But one question related to root locus is must. Okay, so related to root locus, one question would be asked in module 4. Okay, and one question from module 5 is related to Bode plots. Okay, Bode plots, we have not provided the videos for you all, but in a short amount of time we would be trying to provide you the brief explanation about Bode plots and different kinds of problems. Okay, so the direct problem related to Bode plot is, they would be giving you one transfer function, and we should be representing it in the general form, and from that general form we should be trying to write the zeros and poles at origin for different values of dB per decade, and for separately for magnitude plot and phase plot. Separate data you should be providing it, that I would be explaining you later in my concept video. magnitude plot, phase plot. You should be trying to draw the magnitude plot and phase plot, okay, and from that magnitude plot and phase plot you should be trying to calculate the gain crossover frequency and phase crossover frequency, and to analyze the stability. The phase, whenever the phase crossover frequency is greater, the system is stable, and whenever the gain crossover frequency is greater, the system is unstable, and whenever these two values are equal, the system is marginally stable, okay. And also phase margin and gain margin, and that I would be explaining you, that also they would be telling you to ask, okay. So one problem related to Bode plot is definitely asked, okay. So that's all. And also some problems related to Nyquist plot and state equations are pending, but they would be asking one simple problem related to them. So yeah, so from module 5, Bode plots is one question is must, so you should study that. So that's all for this session. I've tried to provide some important kinds of questions and some important type of questions. I'm not telling you that some questions, definite questions, because we cannot predict what they would be asking in this control system exam, because this is a purely what to say, calculative subject, not a theoretical subject, or theory questions are not there in this. Some theory questions related to some derivations are there, but other questions are not there. So that's why I've tried my best to provide some of the videos, some of the concepts, and all the kinds of videos from all the 4 modules. It's available in our channel, so please visit our channel and watch those concepts videos. It would be very useful to you all, because I've tried my best to explain it in a beautiful way, all the 4 modules, okay. Each step-by-step explanation is available, so please refer those videos. And also all the best for your exams. This is a very difficult exam and time consuming exam, okay. The time would be not sufficient how much ever you write, so that's why please try to write it in a very quick manner, okay. Also please like, share, subscribe. Our target is 400 likes for this video. I hope that you would be completing this, so please like, share, subscribe guys. Thank you.